I heard everyone had a great day yesterday in the boat. So now it's probably time to reverse that equilibrium by having a session on brownfield service discovery. Good morning, everyone. I'm Krishna Venkatraman. I also have with me Giri Venugopal and Neha Sahni, my peers, working with different customers on brownfield service discovery use cases. So today we wanted to briefly talk about service discovery, how do we use it, some of the use case scenarios where it has its applicabilities, talk about some of the frameworks that we have used. We won't dive very deep into that, but we'll just provide a quick gist of the different frameworks that we have been using to alleviate and go through this iterative process, intense iterative process. So there are some approaches that we have used, but there is no single magic bullet. So we have used the XSLT based service discovery framework and Python based service, Python, Java, and other transformation based service discovery frameworks. We'll go over that, and then we'll wrap it up with a quick demo. So to begin with, what is service discovery? It is a technique or an approach wherein we end up creating these service instances based on the existing device configuration. So when we are working with customers, pretty much we get to absorb the same sentiment wherein the network is golden. They have these services that have been deployed over several years, probably over a decade, and they really like the powerful NSO tool and the value that it brings on board. But they would not only like to manage services on an ongoing basis, but they would also have to they would like to figure out a way in which they can bring all their existing services that have been deployed over uh, uh, last several years on board into NSO so that they can manage that on an ongoing basis in the future via NSO. So to reiterate, it is a technique to create these service instances from a bottom-up approach. Yesterday we heard discussions on bottom-up versus top-down. So you have all the device configuration. Based on the device configuration that gets absorbed into NSO CDB, the technique to create the service instances is service discovery, and it is required when you're onboarding brownfield devices onto NSO. Typically, it is considered as a one-time activity for onboarding a brownfield device onto a NSO. And we did talk about what is service discovery, and let me also briefly mention what is not service discovery. So a lot of times there is a perception that when we do a sync from, so we get all the data into NSO's CDB. Yes, we do, but that is not service discovery, right? So we do get all the data into the CDB, but we still need a way to map and attach that device configuration data to a service layer or a Yang model that we have defined. So just to reiterate that, sync from is not service discovery, and we go with these uh, hard assumptions that there should be no disruption to existing network. Network services cannot be disrupted. We have to accommodate multiple versions of these legacy device configuration. Um, a lot of times these networks configurations don't adhere to any standards, and they have evolved, and it's critical that with the service discovery process that we go through, we do not disrupt any of the configuration. And we also have to have a way in which we are able to accommodate both service specific configuration and non-service specific configuration. And some of this have been alleviated by latest features such as partial sync, wherein we are able to selectively do a sync from over a period of time. So let's talk about some use case applicabilities as to where we end up doing service discovery. So it's like looking for a needle in a haystack. Um, uh, when we are doing a device onboarding, a device with like probably a couple of 100,000 lines of device configuration, when we are onboarding that to NSO, loading all that configuration into NSO CDB, it is critical that we do the service discovery, absorb all the services onto NSO. We did have a session yesterday. Dan Sullivan, he talked about how to handle out-of-band changes. It is critical that we are able to absorb all the out-of-band changes done in the network as well as part of this service discovery. And I did mention briefly that all these configurations have evolved over a period of time, and we always have golden config templates, or probably few versions of these golden config templates. So we want to have a way to be able to do some kind of a compliance check between the pristine version that we might have and the version that is out there in the network. We might run some compliance check and may not do anything about it, and be cognizant of that, and if we need to take any action at a later time in the network, but it does give us a good snapshot of the compliance check. And sometimes the timers, the ACLs are superseding each other. They're redundant, or they're doing exactly opposite ACL rules. They have exactly opposite ACL rules configured in the network. So how to quickly identify that? So clean them up so that we can eliminate some of these errors introduced because of some contradicting ACL rules and so on, or some incorrect timer values. So running or executing the service discovery tool would help us identify some of those edge cases. And a lot of times when we are working with the operations team and with the team that's responsible for managing the server, it is possible that we might run into some of these disaster scenarios wherein due to an inadvertent error by the operator, it's not NSO's fault, but it just happens with the way we are following the MOP during the package upgrades on a production network. And there are times where we have lost some data from CDB because of an error, manual error that was done. Service discovery approach helps us rediscover or learn everything from the network in such scenarios as well. And there are times some of our customers have been migrating from physical infrastructure to maybe all or some virtualized infrastructure. So they've been migrating existing manually configured services deployed in physical infrastructure to virtualized environments, and they want to do this over a period of time. So they've been able to discover all these services bottom up from the source devices, source physical infrastructure, bring them on board into NSO, and then they were able to push it into one or many one-to-N target devices, which were sometimes virtualized. And as we are working, as the life cycle matures, and as we are transcending through this service development life cycle, so there are times when we are developing features. So I could quote a recent example where we had all these services deployed for IPv4, and which were all brownfield, and as the services were maturing, they also wanted to enhance the services that were deployed to be able to accommodate IPv6 scenarios, and we had to make quite a few Yang model changes, the data changes, right? Like in any typical database migration, like we've always had the ETL tools to do the migration. Similarly, the service discovery framework has turned out to be like a migration tool when we are making all these Yang changes, changing keys, changing some service parameters, and the way in which we can map those or the consequence of those parameters with the device configuration data. So on an ongoing basis, the day 2 Yang schema upgrades have been sucked back into the mapping based on the service discovery framework that we have in place. So how do we do that? So how are we able to do this, right? So we have flashed 2 options here, but also talk about option 3, which is probably the easiest one, wherein you have all the device configuration data, you've gone through the process of having your Yang models and all the service models perfectly constructed and written, and for onboarding greenfield scenarios. So if we are able to go through the process and iteratively build those XMLs, and if we are able to submit those API requests from a northbound as if they were new requests with no networking. I believe there were 2 sessions where they were discussing about submitting these API requests with no networking flags, so that they are able to construct all these service instances without actually writing anything to the network, because they already exist in the network. So that's option 3, which I have not flashed. That's I mean, most of our customers started with that paradigm, but as we were working through some of these device configuration, it became a very laborious and a tedious process to go through that. So that's when we evolved to examine some of these options. For some, I mean, there's no one best formula. In some cases we have used option 1. In some cases we have used option 2 with Python and Java. But the logic is to the crux is to be able to come up with some kind of a transformation logic, wherein we are able to do that reverse mapping between the device configuration and the service parameters. So option 1 is to come up with the XSLT technique, wherein you can write some pretty straightforward plug and play XSLT, bring your own transformation logic, write your own XSLTs from the device configuration templates that you have, and the service model that you have, and they can be applied directly to these device templates. And option 2 is to use Python and Java. So now API is pretty elegant, and we also have the Python APIs to be able to get those and write the transformation logic in either Python or in Java, and to use the action layer that is similar to what Dan had demonstrated in his demo yesterday. So to dive a little bit deeper into XSLT and Python framework, I invite Giri, and then that will be followed by a demo. Thank you.
Thanks, Krishna.
Yeah.
So good morning, everyone. My name is Giri Venugopal, and I'm here with Krishna and Neha to just walk you through the XSLT-based service discovery framework, and also give a demo of how it works. And just take a sample service. We have developed a small custom service for enabling a port, and what we'll be doing towards the end is just we have brownfield configurations that's already existing on a device, and we'll be using our service discovery framework to discover this port turnup service, and just ensure that initially there are no service data on CDB, and after we perform the brownfield service discovery, we would be seeing that the equivalent service instances are created in CDB. So as you can see here, there are multiple approaches to perform service discovery, and we are just discussing two approaches, two frequently used approaches. And the first approach here is XSLT-based discovery, right? So it has two components. So when we try to develop this service, as you can know, a service could be anything, right? Let's say IP, BGP, VRF, IPv4, V6, etc. Right? So if you want to discover, if you want to perform some kind of discovery, you need to create the transformation logic in order to do the discovery. So a part of this is not, a part of this differs from service to service that you're trying to discover, but we have tried the maximum to make a portion of it as reusable. So the first portion consists of the discovery service, which is fully reusable. So the discovery service has these options. So perform service discovery, validate discovered instances, preview service discovery, and import services. So these are all the common actions that you can do to discover any service, like IP, BGP, VRF, etc. Right? So this part is completely reusable. And the transformation layer, like when you want to perform discovery, you need to write your own transformation. So for IP service, you could have a transformation. For BGP service, you could have a transformation. So for VRF service, you could have a different transformation. So this layer is kind of plug and play. So this is going to be varying. So this is the variable layer, and the first part is the generic layer. So the first part exposes all these end user actions. So you can, let's say, when you're onboarding a brownfield device, so what do you want to what do you want NSO to absorb from the device, right? So the first action here, when we just do service discovery, it will just perform discovery, and it will just show the list of discovered instances onto the user. So it wouldn't commit anything to CDB as of now. It would just list the discovered service instances in an XML format, right? And the second action is validate discovered instances. So what we could do is, for example, if we are discovering our port turnup service in our example today, so we would supply, a valid XML as a template to NSO, so that it knows what are the service related parameters that it should expect in order to consider it as a valid service instance. So we would be providing a skeleton, basic XML skeleton of the service instance, and NSO would be validating the discovered instance against this template. So we can provide a set of mandatory parameters and optional parameters by specifying comma separated values. For example, in our port turnup service, I have 3 parameters, out of which one of them is optional. So I can just mention the optional parameters in a file, and we can just ignore, or NSO can ignore when it's validating the discovered instances. Or if everything is mandatory, then it would kind of mandate that all the service parameters should be present in the discovered instances. Unless everything is found, it wouldn't validate the discovered instances, right? So the third action is again preview service discovery changes. So all these actions are cumulatively done. So first is you just perform service discovery. Second is you validate the discovered instances. And the third is you basically do a commit dry run of the discovered instances. So what you do is you just have a list of discovered service instances, valid service instances, and you do a commit dry run on NSO and just see what if at all there are any changes. Meaning, if the network is 100% clean and it is fully sanitized, you wouldn't be seeing any changes here. But if not, 99% of the brownfield devices that have been manually configured over time are prone to errors, right? So they would have kind of missed some configurations, or they would have not adhered to a golden config template. So in all these scenarios, when you do a previous service discovery action, it would just bring out a list of changes that NSO is going to push in order to make them adhere to the service that we are going to discover. So the basic assumption here is we already have the service that we are trying to discover. The service that we are trying to discover is already deployed in NSO. So basically, the thing is, if you have 0 changes here, your network is pretty clean. But most of the time you would be seeing some changes here because they've all been manually configured over time, right? And the last action here is import services. So again, this is done cumulatively. So we discover service instances, we validate them, and once we are okay. So this step is an iterative step. So basically, you need to make sure you see the preview and make sure that all the changes that are going to be pushed onto the device they are all perfect, right? So we need to make sure that these changes are pretty okay with with the network operator. And once he approves them, we can go ahead and import the services, which would basically do a commit. So commit in the sense it would also create the equivalent service instances on CDB, and if at all there are any changes that needs to be pushed, they will be pushed onto the device. So this action is kind of done basically on the assumption that the network operator is okay with all the changes that are being pushed into the device. And one more point that we wanted to highlight was, we can also add some filters. So let's say out of 10 discovered instances, you want to include or exclude certain service instances. So you could specify your filter criteria there, and you can kind of ignore or exclude or include those service instances from being pushed onto CDB. Right, so these are the end user actions that are exposed as part of the generic discovery service. And you can kind of think about this as an ATL layer, right? So extraction, transformation, and loading. So where the extraction and loading is always going to be the same, it's not going to change. Only the transformation is going to be changed according to each service that we are trying to discover. It could span across one device or multiple devices, but as of now, we are just going to see the demo with one device. So this is just a very high level schematic, and I don't think everybody can see the XML here, but that's not important. So the thing is, since we are going through an XSLT approach, it requires some amount of development here. So it's a one-time development. Again, since NSO has native expath capabilities, it's very easy to create the XSLT transformation layer, right? So you can always, whatever we have been doing is just using CDB's native expath expressions. We have been constructing XSLTs, and we have been using it as a transformation as a transformation layer. So basically, what the two files or the two important data that we need to create our XSLT is the device config XML. So for example, in our case, this is the VRF service. So we know that this is our device configuration template. So I'm just going to use this template. Plus, I know what my service instance output or the service instance XML output will be looking like. So I have this information as well, and I have my device config XML template. So I'll just be using both of them because this XSLT is kind of applied over this device template, and the output is going to be your service instance XML. So it requires some amount of developing, but since NSO has a lot of exposes native expat capabilities, it is not a very time intensive or a labor intensive task to come up with this transformation layer. So we have been able to create transformation layers in pretty quick, like for complex services in about a week's time, and we're able to validate them for some service provider customers as well, right? And again, this is pretty much the same thing. So we kind of apply this transformation logic over the device configuration XML, and we come up with the service instance XMLs. So we can look into the demo later. So we have the second approach coming up, and Neha will be presenting them.
Thank you, Giri. So my name is, good morning, everyone. My name is Neha Sahni, and I'm from the Advanced Services EMEA team. In the next couple of slides, I'll be talking about a use case that we have for one of our ongoing projects in EMEA. As you saw from the previous slides, service reconciliation or discovery is a complex process, and a lot, or the design and strategy that you take for service discovery depends on how structured or consistent the original deployment is. So when we analyzed our customer data, we found that there were a few inconsistencies ranging from small things like say port descriptions or other attributes not following the naming conventions that we had set out in our service logic, to bigger things like missing configuration or something misconfigured, for example. So we agreed that we would need certain data sanitization or a cleansing activity before we could run the service discovery process successfully. And hence, to assist in that process, we split our service discovery framework into two steps. So this is the first step, where we discover the service instances, all the service parameters, and then for each of the service in the discovered instances, we do a commit dry run. This would highlight any non-compliant config. We display that to the user, and this assists them in knowing early on what the non-compliant config is, and they could take appropriate action like manual cleansing, or alternatively, they can also, if they're okay to sort of have NSO override those changes or accept the dry run differences, they could pass the service instances to the next step, which is the create services step. So the first step that we talk about, that step can be run iteratively till you're happy with the results. And then the output of that could be passed on to the next step, which is the create services step. So in this step, we commit the service instances. We then do a redeploy reconcile, which is basically taking ownership of the data so that at a later point you can modify and delete service instances through NSO. So NSO manages that service instance. And then as a final verification step, we do a delete dry run. So this is just to just an additional step to sort of validate that we have indeed taken over data ownership correctly. So these are the three steps we do in the second process, or the second step of the process. And of course, I mean, nothing's stopping us from really combining these two steps into one step for a more automated solution. But in this case, we decided to keep it as two separate steps, just to give more control to the customer looking at their data. So that's just, will vary depending on the original deployment. But Yeah, so that was a high-level overview of our Python-based framework. And if we have time, we can probably Giri can show you a quick demo of the XSLT framework. So, and we'll be happy to take any questions after the demo. Yeah.
So we'll be first looking at a quick demo of the XSLT-based approach. So, okay. So we'll be using the native NSO GUI to perform this, to just show a demonstration of the XSLT-based approach. So we have, so this service discovery, oops. So this service discovery logic is, I mean, it's written as an action. So it's deployed in the module section of NSO. So let me go ahead and log into one of the NSO deployments in the lab. So as I mentioned earlier, today we are just going to look at a small service called port turnup. And basically what it does is it just takes in a few parameters like VLAN ID, port type, whether it's trunk or access, MTU speed, etc. Right? So these are just a few parameters, and we are going to basically configure an Ethernet interface. So that's going to be our sample service. So we are going to take this Nexus device as our we're going to use this device for a demo today. So let me first show the configuration. I think it's too small, right? Is it bigger? Can people see it, or is it still small? Okay. So is it good enough? Okay. Or probably I'll zoom a little bit more. Okay. So this is basically my NSO server. So I'm just going to log into NCSCLI and see, just ensure that there are no existing service instances for this particular port turnup service. So if I go to config mode, show full configuration, services, port turnup. So I don't have any service instances as of now because it just says no entries found, right? So, but if you look at the device, so let me also show my XSLT layer. So again, this is a little bit small, but this is basically, I mean, I don't want to go through the logic, but just this is my transformation layer for the port turnup service. So it basically, you can see that it just like, it's a very small service spanning across like 25, 30 lines, right? So this is my transformation layer, and basically I'm just trying to construct the service instance using XSLT here. So that's just what I have here. So I can show you the device configuration. Show full configuration, devices. So device, Nexus 5020, config, Nexus interface, Ethernet 1/1. So as you can see here, we have we have created an interface, Ethernet interface here. So the intent here is to run our service discovery framework and discover the port turnup service that is corresponding to this particular configuration of this interface. So ideally, I would expect once we run the service discovery framework, we need to have an equivalent service of port turnup, service instance of port turnup service, which would basically apply the following configuration here. So let me go ahead and so as you can see here, we have already configured the interface with the basic access VLANs with 100 and a description, and we'll be kind of discovering all these entries using our framework. So let me go back to the service discovery module. So we have deployed this as an action. So service discovery API. So there are a few parameters that you need to specify. As you can see, I think it's or yeah, I think this is good enough, right? So basically, we just need to specify for every run of service discovery, we just need to specify a unique instance ID. Test 123, I'm just going to use it. And the device that we want to perform the discovery on. So I'm just going to choose the Nexus device that we have to perform. And as we mentioned earlier, these are the four actions that the end user can do: run service discovery, validate, preview, and import. So these are the four actions that we showed in the slides. So all these four actions are available to the user, and he can invoke all these four actions to discover any type of service. Right. So first, I'm going to run service discovery, and output base path is basically your local file path where you want NSO to generate the discovered instances. I'm just going to give the path of the same service package. So I'm going to use the packages slash service discovery, and all the discovered service instances would be generated in an XML file in this particular path. And basically the prefix of the service that we are going to discover. So the port turnup service has the same prefix name, and even the service name is the same, port turnup. Oops. Yeah, probably I need to, yeah. So basically, we need to provide the keys. So every service has a key, right? A key or multiple keys. So we need to provide the key fields. So our service has two fields because interface and device. Those are the two key fields for my service. So I'm just going to give those two fields here. And this is basically a leaf list field. So you can provide if your service has composite primary keys, you can provide all the keys here. Interface and device. So those are the keys for my service. And basically, valid XML file is nothing but the XML template which needs to be followed in order to generate the discovered service instances. So if you look at my let me exit out of the CLI, and if I do an ls-al, so I have a couple of files that you can see here, right? So one is the text file where I can specify the optional service parameters, and the second one is an XML file where we specify our valid XML template. So I can do a VI and just show you what is inside the valid service.xml, right? So this is nothing but a stub, or an empty service instance of how my port turnup service would be looking like once it's discovered. So it will have all these parameters here, like device, interface, description, duplex port type, VLAN ID, etc. So we are just specifying, like, this is how my output will be looking like. So if this is missing any of the parameters, just the validate service discovery action would populate the service instances that are not adhering to this particular service instance type, right? So let me go back. And as of now, I don't have any optional parameters in my text file because this is an empty file with 0 bytes. So meaning that all the parameters are mandatory. So that's what I'm specifying here. So I'm just going to give the same path here. Packages, service discovery, and this is going to be my XML file. And my optional parameters also is in the same location, but a different file name. This is my optional parameters file name. Right now, it doesn't have any fields, and we are making sure that all the fields are mandatory. I think I had the slash, yeah. And so when we are performing the service reconciliation, so we have an option either to when we do a redeploy reconcile. I'm sorry, I'm just trying to get rid of this text. Yeah. So basically, the option here that you can see is whether you want to retain or you discard non-service specific configuration. So when this is a flag that's exposed by NSO when you do a reconciliation, whether or not you want to retain your service data, or whether or not you want to retain your non-service specific configuration or not. So basically, we are going to retain the non-service specific configuration, and I'm just going to run the run service discovery action. So I'm just invoking my action here. So we'll be just looking. we'll be having a result pretty soon. Just give it a few seconds. Okay, so there we go. So we have our result here, and I can kind of maximize here. Oops. So this basically says that the service discovery process was complete, and this is my oops. Sorry about that. So this basically says that my service discovery was complete, and this is the path of the output file where the XML has been generated. So let me go to that file, and this is ending in 9748, right? So if I do an LSALTR, so as you can see here, so this is the file that's been discovered. I mean, that's been generated recently as a result of the service discovery. And if I do a VI on that, let me just. Oops. So you can see here that the service has been one service instance has been discovered that is corresponding to Ethernet 1/1. So as we saw earlier, in the device configuration, so all these data has been kind of absorbed from the device configuration in the Nexus device, and we have populated the service instance with all the relevant data that is kind of specific to this port turnup service. So as you can see here, we specified all these fields in the valid XML, and we did not specify anything in the optional parameters, meaning that all the fields are mandatory. So you can see all the fields, all the service parameters that have been discovered, and they have their corresponding values from the config, from CDB, right? So so this is basically the run service discovery. So we haven't done anything so far. We have just performed discovery, and we have generated an XML file with the discovered instances. That's pretty much it.
We need to round off here.
Okay, cool. So
We have time for one question.
sure. Yep.
Is this one? Yes.
So has any thought been put into how this could be generalized to apply to services that span multiple devices?
So yes, so basically we have started off with the single device approach, but once if your service is spanning across multiple devices, we just need to include those devices in your transformation layer, and just need to write the corresponding XPath expressions for each device, so that there is a correlation between each device that you're trying to configure as part of your service. So this sample service that we saw is just spanning across just one device. But if you have a service that's spanning across multiple, we just need to have the transformations for all those devices as part of your XSLT.
And we have also had this working against stack services. So stack services, in another way, is aggregation of multiple instances, and then combining them together to construct a single service instance XML. So yes, it is possible to do that across multiple devices, make it span across multiple devices with stack services as well.
Thank you very much, Neha, Giri, and Krishna.
Sure, thank you.
Thank you.